Okay, so here's one where we're just calculating. These are kind of the typical problems that we're going to do, calculate surface areas and volumes. Okay, I'm going to start with a volume. I'm just going to do the volume in terms of finding an area again. So I'm going to find the area of that face. Okay, so that's going to be 120 centimeters squared. And again, make sure that if you haven't done this yet, pause the video, do it yourself, and check over the solution as I've gone over it. Okay, so this is going to be 20 by 6. This rectangle up here is going to be 9 by 10, so this is 90 centimeters squared. So my volume is going to be my area. Okay, so since it's a prism, every slice is going to be that L-shaped. Okay, it's going to be the area of 90 plus 120, or 210 centimeters squared. And then we're going to give it that volume some depth. Okay, so some of you may have done this a little bit differently, doing the two rectangular blocks and adding them together. Okay, if you do that, that's perfectly fine, nothing wrong with that. But you should be getting the exact same volume that I get. Okay, so this is going to be 1,470 centimeters cubed. That's your volume. Okay, for the surface area, again, we want to draw our net. Okay, you need to be able to draw nets for one thing, but the nets also help us keep these surfaces organized. Okay, so I'm going to have the bottom of that. I'm going to have the top. Okay, that's going to be the top there. I need the toe here. I need the top of the L. Okay, that's surface there. I'm going to need to have I'm going to call that the shin, the front surface over in here. Okay, so we've calculated this already as 210. 210. The bottom is going to be a 7 by 20, so 140. The top is going to be a 10 by 7, or 70. Okay, the back, this back here is going to be 7 wide, 15 tall, so 105. Okay, the toe, oh, which way am I going here? Okay, so this would be the toe. Yeah, I think I've done this a little bit differently. That should be the toe up there. Okay, so that's going to be 42. Again, it's important to keep track of these things and make sure you have the right surfaces. So I'm going to say that that's 42 is going to be the front. I'm kind of going this quickly, so I should maybe slow down and just double check, make sure I have my surfaces accounted for. Okay, so then it's going to represent the top. It's going to be 10 by 7. This length here is going to be 9 and 7 wide, so it's going to be 63. And then this surface here is going to be 10 this way and 7 deep, so it's going to be 70 here. Okay, so there I have all my surfaces. Add up the surface area. So my surface area is going to be 42 plus 140 plus 105 plus 70 plus 63 plus 70 plus the two 210s, so I'm going to say 420. Okay, so I'm going to have 5, 7, 10. There's going to be 50, 90, 160, 220, 290, 310. Okay, I'm going to put the 3 over here, 300 and 400, 500, 910 centimeters squared of surface area. So my surface area is equal to 910 centimeters squared. Okay, the last one, oh, there's a couple here. So this one here, volume is, when we calculate the volume of this, I need the volume of the block. So it's going to be, I'm just going to do length times width times height. Okay, and then I want the volume of this cylinder. So it's going to be pi. Okay, the radius is going to be half the diameter of 2 pi r squared, and I want the height of that. So if the whole height is 10, the height of this piece here should be 6 because that's going to be 4 plus 6. So I'm going to use 6 as my height. So working this out, I get 800. Okay, 800 centimeters squared plus, I'm going to get 24 pi. That's centimeters squared. Okay, if you want to convert that to a decimal value, okay, using my calculator, I'm going to get 800 plus 24 pi, and that's going to be 875.39. I'm just going to say 0.4 centimeters. Sorry, this is centimeters cubed because we're talking volume. Centimeters cubed. Okay, so the surface area for this, the way we can set this up is really we can think of this surface separate from the top, but really if we just take that top circle, that we're going to have a hole in our rectangle here, so we really can just fill that hole. So when I talk about my surfaces here, I can draw my rectangular block. I've got a hole in it, but I've got a hole in there, but really I can fill that hole with the cylinder top. So I'm not going to calculate this as I'm not going to take away the hole and put the hole back in. I'm just going to calculate as one surface. Then I have my side cylinder surface. Okay. So calculating these surfaces then, this is going to be the bottom, the top, the side surfaces looks like it's 10 by 4, so 40, 40, and the longer side surface is going to be 20 by 4 or 80 and 80. This is a side surface of the cylinder, so it's going to be the diameter times pi width times 6 height, so I get 24 pi as my area. So my surface area, when I put this all together, I'm going to have 480, 560, 600, 640 centimeters squared plus 24 pi centimeters squares. Okay, so that's exact value. And again, the decimal value, which I don't really need, but I prefer the pi value. The decimal value works out to be about 715.4 centimeters squared. Okay.